all three of the rules that we've talked about this week, starting with the product rule, right? Multiply like bases, add the exponents.
Yeah.
We had the quotient rule, where we divide like bases and subtract the exponents. And we had the power rule, where when we raise a power to another power or an exponent to another exponent, we multiply the exponents, right? Now, naturally, you would think, oh, the next rule that we're going to learn, we're going to divide the exponents. That's not the case. We never actually divide two exponents together. We only ever add, subtract, or multiply, okay? So now what we're going to do is we're going to take all three of these rules and we're going to kick them all up a notch by introducing a product base, okay? A product base. What was a product again?
Multiplication.
Yeah, the answer to a multiplication problem. And what is a base?
The big number.
The big number that has a little what on it?
Exponent.
An exponent, right? So take a look at this right here in this little dotted circle. How would I read what's inside this dotted circle? If I said, what does that say? What would you say? 2x to the third power. Exactly. Now, if you look back, right, every time we had an exponent on something, it was just one little thing with that exponent.
Yeah.
Either it was 2 squared or x squared. But now we have 2x to the third. Okay? This is what a product base is. So with this term, the base for your exponent of 3 is, what do you guys think? What do you think my base is here?
X. Or no,
Some people say 2x. Give me a thumbs up if you think my base is 2x. Give me a thumbs down if you think my base is just x. Good. Lots of thumbs up. People saying 2x. Good. You're all wrong. Okay?
It's 2.
X is my only base here.
That's what I meant.
Oh, that's what you meant? I'm sure. That's
I knew
good.
that. I was just throwing you off.
So this is good though, because this is why I said this is a little bit more challenging, because people see this and go, oh, my base is 2x. No, no, no. The 3 is only attached to that x. My 2's just out in front hanging out, okay? Does anyone remember what we call the number in front of a variable?
The front number.
Coefficient.
Mr. Church, can I charge my Chromebook?
Just throw it over there on the table, yeah.
Bro, what?
So my exponent 3 is attached on the base x with a coefficient of 2 out in front. Right? This is different than if I were to say 2 to the third, x to the third. These are two different things. In this case, yeah, 2 is a base and x is a base. But over here, with what we're going to be dealing with, 2 is like a completely separate thing. X is my only base with that 3 up on top. Give me a thumbs up if that makes sense so far.
Yeah.
Okay. What doesn't make sense about it? What question can I answer to clarify before we go on?
I understand it now.
What's that? How can the coefficient be 2? The coefficient can be anything. It's just whatever number is being multiplied by that base. The important thing that we need to note is 2 is not a base. Okay? It's 2 times... Okay, let's not sneeze then. I forgot what I was saying. Whatever. So the coefficient in front is going to be treated like a separate problem. That's kind of what I said. You could break it up to make things easier when using each of these 3 rules. So let's go rule by rule and see if this makes sense, right? Let's say I've got 2x to the third times 4x to the fifth. Everybody's got a highlighter on them? Yeah? Everybody's got 2 colored highlighters on them? Okay. So, in this first problem, with my yellow highlighter, I'm going to highlight what my coefficients are. Who could tell me what my coefficients are in this first problem? 2 and 4. Okay, just this problem right here, buddy. 2 and 4. How do I know that 2 and 4 are my coefficients?
You're in front.
Because they're in the front. Do those two, or does that 2 or that 4 have an exponent attached to it?
No.
No. It does not. It's just a 2 and it's just a 4. So what we're going to do is we're going to kind of combine like terms in a way. We're going to take out the 2 and we're going to take out the 4 and we're going to treat them like their own separate multiplication problem. Right? So imagine these yellow coefficients aren't there anymore. X to the third times x to the fifth. Well, that's a nice easy product rule problem that we're going to treat like a second problem within this problem, right? So we're splitting up essentially our like terms. The 2 and the 4 are like terms because they're just numbers. The x to the third and the x to the fifth are like terms because they're both x's. Everybody see how we split that up? Does anybody not see how we split that up? Okay. Now we're going to solve the yellow equation, get that product. The pink one, get that product, right? What is 2 times 4? 8. That's right. And if I'm multiplying my x's, my base x's, what should I do with those 2 exponents?
Add them.
I'm going to add them. It's the product rule. If I multiply like bases, I add the exponents together. You writing this up?
Yeah.
Okay, stop talking.
Oh, yeah.
Thank you. If I add 3 plus 5, what do I now get as my power of x?
8.
8. So this turns into 8x to the 8th. Have you take a moment, see if you can digest that, figure out how we started versus how we finished. Once you see it, it's actually fairly...
I get it now. So the variable is the base, right?
Yep.
And I'll
Yep.
it's easy.
Give that second problem a try. Negative 3b to the fourth times 2b to the second. See if you can use what we just talked about. Definitely want to use your highlighters here.
Can the base be negative?
Can the base be negative?
No.
No.
Never.
Well, it can, but we don't need to see all that. What's negative in this is the coefficient.
Oh, yeah.
Yeah, the coefficient can definitely be negative.
No.
If I multiply a negative 3 times a positive 2, I'm going to get a negative coefficient. Get another one. I got it. Thank you. Thank you.
I hate little girls.
Is that that's a 7th grade class already?
Yeah, it got
I could tell. So I can't teach 7th grade. Let's sell insurance before we teach 7th grade.
You said what?
No.
Yes.
You'd rather sell insurance.
All right, what are my coefficients here in the second problem?
Negative 3, 2.
Negative 3 and 2. I'm going to bring those out in front so I can multiply them. And then I got my base b. What are my powers of my bases b's?
4 and 2.
4 and 2.
I'm kind of getting this now.
That's good. All right. So my new coefficient, negative 3 times 2, becomes what?
Negative 6.
Negative 6. There we go. Took a second. We got it. Negative 6 times x to the power of, I know that I'm going to add my exponents because I'm multiplying the bases. So I got 4 plus 2. What's my new power of x going to be? 6. So I get negative 6x to the 6th.
Wait, you don't have to do the 1 over or that over.
Good
1.
question. Good question. When do I know I need to put it over 1 and flip it?
Exponent.
When the exponent is what?
Negative.
Negative. Do I have a negative exponent here?
No.
No, so I don't need to do that. Alicia?
If you do have a negative exponent and a negative constant, if you flip it, does it make them both positive?
Good question. I'm glad that you asked that. I don't think it's going to come up because it typically gets really confusing, but let me show you. If I had negative 2x to the negative 3, right? This is what you're talking about, if they're both negative. So because these are two separate things, this is the only thing with a negative exponent, which means I basically split it up like this, right? If I separate them, I put this one over 1, flip it around and make this positive, right? So 1 over x to the third, and then I bring down my times negative 2. I'm going to multiply that by the top, and I get something that looks like that, right? So because x is the only thing with a negative exponent, that's the only thing that gets flipped. That 2 stays where it's at. I don't think this is going to come up. Next year, you'll dive deeper into this and do stuff like that. That's a great question. Yeah, great question. We only ever flip when the exponent is negative, okay? If the coefficient's negative, it's just a negative coefficient. That's fine. Give me a thumbs up. You're good on power of a product. Good. Let's do power of a power. Right? This is a continuation of what we talked about yesterday. Yesterday, we just saw this. X to the third raised to the second. And that would tell me that I do what with those two exponents again? I'm going to multiply them. So I'm going to hit x to the third and that little 2 with pink. What's my coefficient here? 2. Is that big 2, is that a base?
It's coefficient.
It's a coefficient, not a base. All right? So I'm taking everything inside the parentheses and I'm squaring it, meaning I'm writing it 2 times. What does that look like? Well, that's 2x to the third times 2x to the third. All right, I'm writing out everything inside the parentheses 2 times because that's what the exponent tells me to do. Well, now this looks exactly like the rule we just talked about, the power of a product rule, right? So what should I do with those 2 yellow 2's out in front? I'm going to multiply them. I'm going to bring them out in front, and I'm going to multiply them. What would 2 times 2 give me in front now? 4. And then I'm going to rearrange my x's. What am I going to do with those 2 powers of 3 on those x's? I'm going to add them together. I'm going to use the product rule. I'm going to add them together, which gives me a final answer of 4x to the what? 6th power.
Wow.
Now this way, we'll call this method 1. It's not as practical as what we're about to talk about with method 2. Okay, method 1 really only works if I have a low exponent on the outside. If I had a 6 out here, you think I'm going to write this out 6 times and then write 2 times 2 times 2 times 2 times 2 times 2? No, I don't have time or energy for all that. Method 2 is what I want you to do. Here's method 2. You guys ready?
Yeah.
What's my outer exponent in this second problem?
3.
3. What I'm going to do with that 3, just like yesterday's power rules, I'm going to distribute it. But now I'm not just distributing it to this x. I also want to distribute it to what?
Coefficient.
The coefficient. Exactly. This 3. So this becomes 3 to the third times x to the, when I power to a power, what do I do with that 4 and that 3? Do I add them? I got to multiply them, right? Give me a thumbs up if you see what I did there with method 2. Emerson sees it, Araya sees it, Khalees sees it, Gianni and Julian see it. Right? This helps us not have to write out this whole big ol' long thing, right? Because now I can just do 3 to the third. What's 3 to the third power? 3 times 3 times 3? 27. And what's my new power of x going to be? 12. Look at that. That was way easier for me than what we did in method 1.
That was way quicker.
That was awesome sauce.
I'm going to highlight here just so it all looks okay. Right, so the coefficient, whether we're doing the product rule or the power rule, the coefficient is treated like a completely separate problem from what I'm doing with my base variable, right? Everything that we do with these product-based rules, the base of my exponent is always going to be a variable, all right? Because I need a coefficient or a number out in front. How's this one sounding? Give me a thumbs up, sounds great. Thumbs sideways sounds okay. Thumbs down, it sounds bad.
What do we say?
Okay. You guys ready for the harder one?
Yay!
All right, let's do it.
What do we forgot my corn book at?
Thank God.
Bro.
Once you get the second page, go ahead and glue it in.
Give me that, bro. Bro, I can't take it anymore, bro. No!
If you think you can't, you won't. Every notes video we've ever done is posted in Google Classroom. So when you get home and have your kids tell them when we work on the worksheet, just watch the video and run through the notes. It'd be better if you actually like take a little bit of time to listen to it as opposed to just blindly copying it. Because if you copy it all down, yeah, you have it, but you don't know what it means.
Yes.
Oh, yeah. This part is important. I'm gonna have you stay for this.
I don't know, it's because they were, I do have people put them on, playing or watching that shorts.
I did not.
It says, I do. He said that he was setting stuff on. Mr. How are you off on?
I think I have a picture of him. Everybody has it.
It has an edge, but not a crust.
To the edge, no.
All right, let's take a look. Everybody got this glued in? Question. Not right now. This is important. Thank you for waiting. So we did the product rule, we did the power rule. The quotient rule is the more difficult one because we're dealing with two levels here, right? We got our numerator and we got our denominator. It's not just everything out in a line. So we're going to talk about two ways to do this. Some of you will feel better with the first way. I need you to focus. Okay? Can you do that for me?
Yes.
Thank you. We're going to do this two different ways. Some of you may be more comfortable with the first way. Some of you may be more comfortable with the second way. It is up to you to decide which way you want to do it when it comes to the worksheet, when it comes to the test next week. All right? I am fine with either. That's why I'm teaching both of them. You need to make sure you're paying attention to both so you can figure out which one's easier. Okay? Let's start with this. We got 8x to the 6th over 2x to the 3rd. What are my coefficients in this problem?
2 and 8.
2 and 8. I'm going to hit those with my yellow highlighter. What is my like base in this problem? X. And x has the powers of what? 6 and 3. So just like in the previous two, I'm going to split up my equation into, or my expression into the yellow coefficients and the pink powers, the bases with a power. All right? But they're going to both be in fractions because we're dividing. What is my yellow fraction of coefficients going to look like? 8 over 2. Great job. And I've got my x to the 6th over x to the 3rd. Everybody with me so far? Yeah? Can I simplify 8 divided by 2 at all? Yeah, what is 8 divided by 2? 4. So my yellow fraction becomes 4. And when I'm dividing like bases like this, what did we learn that we need to do? I think it was on Monday we learned it. What do we do with those exponents?
We minus them down.
We're going to minus. We're going to subtract them downward. Exactly. 6 minus 3. Everybody with that? Okay. So my 4 is my new coefficient. That's out in front. What is 6 minus 3? 3. Yep. There's my answer. 4x to the 3rd. Now, notice the top versus the bottom. Which side has the bigger coefficient, the top or the bottom? The top has the bigger coefficient. For my powers, which side has the bigger power, the top or the bottom? The top. So because the top had a bigger coefficient and a bigger power, we ended up with no fraction at all. You guys see that? What about this second problem? Who has the bigger coefficient, the top or the bottom? The bottom. What about the bigger power? The bottom as well. So let's see how that's different. Again, still using this first little method of splitting them up and solving them as separate problems. My coefficients are 4 and 12. I'm going to bring those out in front. My powers are 2 and 5. I'm going to separate those off to the side. Still doing fractions, just separating them into two separate fractions. Right? Now, if I want to simplify 4 over 12, right? I want to split up as much as I can. What do we notice? Does 12 and 4 have anything in common? A 4, right? Well, 4 times what gives me 12? 3. So I'm going to turn this 12 into a 4 times 3. And on the top, 4 times what would give me 4? 1. It's important that we do that as well. You'll see why. What am I going to do with my powers here? Because they're in a fraction, I know I need to do what? Subtract down. Now look at my yellow split up fraction. Is there any like factors on the top and bottom I can cancel?
4.
Yeah, I can cancel out the 4's. So that leaves me with 1/3 a to the power of what? Negative 3. Is that my final answer? No. Right? I still do not want negative exponents in my answer. So what can I do with this a to the negative third? I can make it into a positive. I'm going to put it over 1. I'm going to flip it around, and I'm going to make my exponent positive. So now I still have that 1/3 in the front times 1 over a to the third I know this is a little bit confusing, right? It's kind of a lot going on. But now I want to bring these two fractions back together. I want my answer to be one single fraction. What's my numerator going to be if I do 1 times 1? Well, what's 1 times 1? 1. And what's 3 times a to the third? 3a to the third. So notice how I had a smaller coefficient and a smaller power on the top, and my answer is still a fraction. Okay? Give me a thumbs up if you're confused by this second one. I'm confused. It's okay if you're confused, because we're going to learn a much easier way to do this in just a second. So the first one, not too bad, right? If I have my bigger numbers on top, it comes out nice and clean. If I've got my bigger numbers on the bottom, now I'm doing all this negative exponents, switching around, multiplying fractions. That's messy. I don't like that. Okay? Let's figure out a better way to do this. When in doubt, what should we do? Do you guys remember?
Expand it out.
Expand it out or space it out. Take a look. I'm going to highlight my 6 and my 8. Those are my coefficients. I've got x to the third and x to the sixth. Those are my bases with powers, my like bases with powers. Now I'm in doubt. I see I've got a smaller number and a smaller power on the top. If I remember from my notes, that got really ugly and I kind of got confused by that. So I'm definitely in doubt right now. What can I do when I'm in doubt? I can expand it out. Let's go piece by piece. How can I expand out 6? 3 times 2. Right? Everybody agree that 6 is just 3 times 2? Okay. How can I expand out x to the power of 3?
1, 3.
What's that?
1 times 3.
1 times 3? Not quite.
X times
x
X.
times x times x. You see that? Yeah. So 6x to the third, if I break it down into all its little parts, is 3 times 2 times x times x times x. Bring those all back together. Boom, I got 6x to the third. With me so far? Let's do the same thing on the bottom. How can I split up 8? What two numbers multiply to give me 8? 4 times 2. Can I split up 4? Yeah, 2 times 2, right? So 8 is 2 times 2 times 2. We want to split it up as much as we can. You'll see why in a second. How can I split up x to the 6th power? What would that look like? 6 x's, all multiplied by each other. 1, 2, 3, 4, 5, 6. Now you may be looking at this and going, I thought you said this was the easier way of doing it. And it actually is, at least in my opinion. You might think the other way is easier. But I think this is easier. Because what we're going to look for now, just like when we first talked about the quotient rules, we're looking for things in common that I could just cancel out. Let's start with the numbers, all these yellow numbers here. Are there any numbers on the top and bottom that create a matching pair? Yeah, I got a pair of what? 2s. I'm going to circle up those 2s. And I'm going to cross them out. Away they go. Because what's 2 over 2? It's 1. So I can just get rid of it. How many x's can I circle up on the top and bottom that make matching pairs? 3 pairs. 1, 2, 3. Those are all going to go away as well. Is there any other matching pairs I can cancel out? No. What we need to do now is just bring everything back together. What's the only thing left in my numerator? 3. What are the numbers left in my denominator? 2 times 2. Well, what's 2 times 2? 4. Do I have any x's on the top? No, they all canceled. Do I have any x's on the bottom? Yeah, how many do I have?
3.
Well, how can I write 3 x's if I want to bring them back together? X to the third. There's my answer. Just like that. Question. How did I get all those x's? The exponent on that x tells me how many times I'm writing it, right? So if it's x to the third, I write it 3 times. So the 3 and the 2 comes from the 6, right? If I break up 6, that's 3 times 2. You agree with that? 8 is 4 times 2, and 4 is 2 times 2. So 2 times 2 times 2 gives me 8. Does that make sense? Good question. So look at all that. Look at all these steps that we did versus this. Now, yeah, breaking it up is kind of annoying, but trust me, it is way less work, especially when we are bottom heavy in these fractions, right? Let's see what happens when we're top heavy. We'll go back to this 9b to the 5th over 3b to the 2nd. Let's split this up. How can I split up 9? What 2 numbers multiply to give me 9? 3 times 3. And how many b's do I have on the top? I got 5. When I expand it out like this, I don't have to worry about negative exponents. How can I split up 3 on the bottom? 1 times 3. And how many b's do I have on the bottom? 2. Are we all expanded out? Yes, we are. What numbers, right, what coefficients are in common that I could circle up and cross out? 3. I got a pair of 3s. I'm going to circle them up, cross them out. How many pairs of b's can I circle up and cross out? 2 of them. B's right there, b's right there. All those b's go away. Right? Give me a thumbs up if you're with me so far. Okay, I'm doing this one without the color coordination so we could see. What's my coefficient on the top that's left? 3. How many b's do I have on the top? 3 of them. So b to what power? Third power. How many what coefficient do I have on the bottom? 1. Do I have any b's on the bottom? No. So I get 3b to the third over 1, which is just what? Do I need that 1 on the bottom? No. So what can I write? 3b to the third. So just like when we use the other method, if I have a bigger coefficient and a bigger power on the top, I end up with a non-fraction answer, yes? But when I have those smaller numbers on the top than I see on the bottom, I still remain as a fraction 95% of the time. Okay? Give me a thumbs up if that second example kind of makes sense. Yeah? What I want you to do now is I want you to try this third one on your own. See if you can split up 12. Split it up as much as possible. Yeah, you can do 6 times 2, you can do 3 times 4, but 6 can be split up and 4 can still be split up. So split up as much as you can. See what you can circle up and cancel. And And then in 120 seconds, we'll take a look at it. 2 minutes. Yeah, 2 minutes. Give it a try. Can you give this a try? Yeah, that's perfect. Great job. Good start, Dave.
Hate those.
So what you're doing is 2 plus 2. That would be I would. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32 times 2 is 64. Oh, it's crazy. Bottom is perfect. But 12 is 4 times 3, right? And 4 is 2 times 2. So the total breakdown would be 2 times 2 times 2.
5 and 2. 5 and 2.
Let's do this later. Let's work on breaking this. What do you know?
I was helping her do similar
We're not doing statement.
I'm not sure what this.
Good. So this is why we gotta break it up all the way, right? What is 4? 4 is, and what is 10? Yeah, look at all those 2s now. I can start canceling out some numbers. Yeah, because, so you simplified it like halfway. You simplified the variables perfectly. That's great. We gotta simplify the numbers, coefficients too. That looks great. Yeah.
Right?
Oh yeah.
Oh, you got one more thing to cancel. Yeah, you gotta split them up all the way.
Is this Robert's tube? Is it right?
Yeah, yeah, yeah. Looks great.
And I know where Alabama is.
That was good.
Ready?
Oh, you forgot the wine on top. There's one wine. Cancel one of those, and then we're left with 2 on the bottom. Great job, baby.
Is this right? No, I accidentally named it right.
There's 3 Y's down here. So yeah, the Y's are perfect. Think about it like this, right? If I cut out a 4 and a 4, now I've got 3 over 5. 3 over 5. Yeah. So you can think of it like, what do these two have? What's the biggest factor these two have in common? Or you could split it up all the way and cut down all the tiny numbers. Yeah, one of the two. What did you get?
Should I put dinner in here?
All right, looks like we're doing good. Question?
Yeah, I was gonna ask about it, but I guess we'll finish though.
Oh, here, I'll take a look first. Diego, take a seat.
Sorry, yes, sir.
Okay, since that doesn't have an exponent, but this one does, so that means.
Okay, so when we're breaking these down, we're looking for numbers that always, right? What is 6 times 2? That's 6 plus 6.
Oh.
Right? So when I'm breaking down 12, I want to ask myself, what 2 numbers multiply to give me 12? What would you say?
I'm gonna make it back up.
Sure, your class right now.
I know I'm
3 times.
trying to save. Wait, no. No, I got it right. 4 times.
3 times 4, right? So if I turn 12 into 3 times 4, what could I turn 4 into? 4 can be breaking down more, right? What 2 numbers multiply to give me 4?
I'm trying to get it out.
Times. Yes. So this time is 3 times 2 times 2. How many Y's do I have on the top? Do you see a Y? I got 1, right? That's what it is for 1. That's what we're talking about. Times 1.
What?
Instead of 2 as well. Right? Because 3 times 2 is 6. 6 times 2 is 12 times 1.
A little bit.
Good. Now 20, right, is 10 times.
2.
Okay, and then we can break 10 up into 2 times 10. 2 times. I'm sorry. Here. I'm going to break it down up here. We'll see if it makes more sense, okay? I know. All right, my bad. Let's take a look. Do you guys know what a factor tree is?
Yeah. See the stuff.
You guys know what a factor tree is?
Oh, wait, yeah, I heard.
If I wrote 12 like this, does that look familiar? Okay, this might help us break these numbers down because some of us are thinking addition. We got to always be thinking multiplication, right? So if I was going to split 12, what two numbers multiply to give me 12?
6 times 2.
6 times 2 or 3 times 4. Both of them will work because we're breaking this down all the way. Can I split up 2?
No.
No, so I'm going to circle it. Can I split up 6? Yeah, what two numbers multiply to give me 6?
3 times 2.
3 times 2. Can I split up 3? No, right? So 12 is just 3 times 2 times 2. I'm going to write that up here. 3 times 2 times 2. How many y's do I have in the numerator?
1.
1, because this y's got an invisible 1 up there. Can't forget about it. Now, if I was going to make a factor tree for 20, what two numbers multiply to give me 20?
10 and 10.
10 and 2 or 5 and 4. Can I split up 5?
No.
No. Can I split up 4?
Yeah.
Yeah. 2 times 2. So on the bottom now I've got 5 times 2 times 2. How many y's do I have on the bottom?
3.
3. All right, everybody with me so far? Yeah? Let's focus on the numbers. What numbers can I circle up and cross? 2. How many pairs of 2's? 2 of them. Boom, boom. How many y's can I circle up and cross out?
1.
Just 1. Boom. Anything else to cancel? Nope. Let's bring it back together. What's the only thing left in the numerator? 3. What number is left in the denominator? 5. And how many y's are left? 2. There's my answer. Okay? Jawad.
Is it okay if I simplify my answers? 3 over 5? Because like, at first I got 6 over 10 and I simplified to 3 over 5.
Yeah. Yeah, so you did, I'm assuming you did 6 times 2 over 10 times 2?
Yeah.
And you canceled out the 2's? So then you had 6 over 10y squared?
Then I simplified.
And then you simplified it again? Absolutely. So that's, what you did is not wrong. It is an extra step. So if you want to save yourself a little bit of time, break the numbers down completely. It's called prime factorization. Does that sound familiar to anyone? Yeah. Break it up into its prime numbers. You're not going to have to simplify at the end because you're getting all your simplifying done when you cancel. Great question. Give me a thumbs up if that's what you got all on your own. 3 over 5y squared. No? If you got something different, that's okay, but does that make sense how we got 3 over 5y squared? Okay. Like I said, these fraction ones are more difficult, so they are